The future of Scala will be bright, I can tell you that. Okay, so I am Paweł Marks. I am part of the compiler team and also member of SIP committee. And having these two roles, I have unique perspective on development of Scala and changes that are coming to this language. So today, I plan to give you my perspective on that. First, we will start with our journey so far, because for us, previous releases of Scala 3 are just a past, but lots of you are still on Scala 2, so those will be future for you. I will talk shortly about release cycle, so you will know this secret why, if my issue was resolved 2 weeks ago, why it is still present in the compiler that was released a week ago. Then we'll travel to the road each feature must take from being idea in someone's mind to being stable and supported in the compiler and in the tooling. Then we'll talk about the future. Okay, so Scala 3.0 was released in May 2021. This was the first stable release of the compiler. It took everything that was good in Scala 2 and everything that was improved through the years in Scala 2, but streamlined it, made it more robust, and generally was intended to be more expressive version of Scala 2. And I think we managed to do that. This release was followed by 2 patch releases, 3.0.1 and 3.0.2. Then the controversial release came out, Scala 3.1. People were so used to thinking in terms of Scala 2 when each release that is changing the second number is completely new language. You cannot use libraries that were compiled with Scala 2.12 in Scala 2.13. Those have separate ecosystems. And the only way the language doesn't fall apart is that we have cross-publishing. So people haven't even finished migration to Scala 3.0. And what? Now they need to cross-publish to Scala 3.1? Fortunately, that was not the case, because Scala 3 finally is following the semantic versioning. So 3.1 is backward compatible with 3.0. You can compile any code with 3.0, and every future Scala 3 version will accept that, can take it as a dependency. So once you release your library with 3.0, 3.0 can depend on the 3.1, 3.2, and future versions. This is about minor releases. But as you realize, we have something that are called patch releases. So those things, and those are generally both backward and forward compatible with each other. So basically, of course, we are fixing some bugs and adding some usability improvements in patch releases. But for output of your compilation, there should be no difference if you compile it with 3.1.1, 3.1.2, or 3.1.3. So this, as I said, controversial release came out in October 2021 and introduced few new things. I think the most important of them were possibility to configure warnings, so the wconf flag, and the no-warn annotation that was also able to suppress warnings. And of course, it added the possibility to generate mirrors for hierarchical types. It was then followed by 3 patch releases, so as you can see, it was stable for quite some time. Then, a year later, in September 2022, Scala 3.2 was introduced. This was the big release. It introduced many different things, including support for S coverage, possibility to declare export in the extension clauses, and code completions for refined types. This feature, I think, will be very important in the future, and I will show you why. And also it introduced statistics about code complexity, so you can profile your compilation speed. See what parts of your code base are causing compilation to be slow and possibly fix that. This was followed by 2 patch releases, 3.1 and 3.2. The later is the current stable release of Scala. What's next? Scala 3.3. When it will come? Soon. Right now we are in the RC3 territory. Few weeks ago, I was quite sure that we will be able to do the release just before the Scalar Conference or at the Scalar Conference. But you know how it is with releases that are, when releases are, we are trying to time releases with conferences. It never works out. So here we have still some work to do, and this release will come in 2, maybe 3 weeks from now. It will be another big release. It will introduce linter. It will make braces for function parameters optional. It will introduce boundary break abstraction that you've seen today in the Martin's talk, and a new implementation of lazy vals that would make code using algebraic effects, especially in parallel environments, possibly much more efficient. But the one most important thing about this release is that this is a LTS, so long-term support version. What's the deal with LTSs? You have probably realized that all the previous versions, so 3.0, 3.1, 3.2, were only receiving patches where they were the newest minor version of Scala. So once we released Scala 3.2, there were no more patches for Scala 3.1. This won't be the case for Scala 3.3. We are guaranteeing it to receive patches with bug fixes and usability improvements for at least 3 years, probably much longer. This release is intended for users that are more conservative and don't want to bump their dependencies so often. So basically, big companies. Okay, so this is how it looks from your perspective, from users. Those are releases that you see. How it looks from our perspective, from the perspective of the compiler team. Basically like this. So we have concept of something that I like to call a release window. So let's imagine we are here. The current stable version of the compiler is Scala 3.2.0. Then the time we call release window comes, and we are taking our current release candidate release, so in this case 3.2.1, and promoting it to the stable release. We are just building the same artifact once again with different version number, so we know that it behaves exactly the same, and this becomes the new stable release. In the same time, we are branching off from our main branch the new release candidate. That will have higher number. So in this case, 3.2.2 RC1. Our main branch have a continuous development. So we don't really care much about what version we are developing. We are just continuously every day merging new fixes and new improvements. And when the release windows comes out, we are just branching it off. So we will know in advance what will be in the next release. This gives us some time to test the release candidate. More about it in a second. Okay, so after some time, the next release windows came. So now our RC is promoted to 3.2.2, and we are branching off the next. In this case, it will be 3.3.0 RC1. As you can see, this has some unforeseen consequences, and consequences that most of our users don't know about. So if the current released version of the compiler is 3.2.0, the version we are working right now on is not 3.2.1, but 3.2.2, that is developed on the main. Okay, so how long does it take between two release windows? Our original goal was for it to take 6 weeks. But as you know, what works in theory sometimes don't work in practice. And as I said, the goal of RC releases is to test stuff. So we have two sources of knowing about if there are new bugs in given RC release or not. First of them is open community build. Every time we release RC, we are taking all the projects from Scala decks that compiled with Scala 3 even once and try to compile them with the new RC version of the compiler. Then we will see if we break anything for anyone. And usually we do. So we are getting back and fixing that. Of course, you can also help us with testing that, because in your project, you can try to build it with RC version of the compiler and report a bug to us. Then we will be also able to fix it. So when we know about some bug and we fix it, we are merging it to this RC branch, and we are releasing a new RC. And this new RC, when the next release window came, it will be promoted to the new stable release. So usually we are doing at least 2 RC candidate. Right now, 330 will need the 4th release candidate, which I hope will be the last. And this, of course, takes time, because we are guaranteed that every RC release that is promoted to stable release must be at least 1 week old, and also fixing bugs takes time. Reviews takes time. Seeing if anything new wasn't broken by your fix also takes time. So usually, these release windows are not so often. Usually, they more like 8 to 12 weeks apart. So, now I will say more about the futures, where futures came from. So each future starts as an idea in someone's mind. Then there are few steps that it need to underway until it became stable future. So let us see the road of the future, starting from the back, and at which step I will try to show you some examples of this future, so you will see what will be coming to Scala in the not so distant future. So stable futures are just futures. So one example is what I already said about, so optional braces around parameters. This is becoming stable in Scala 3.3. So the code that right now needs to be written like that, from 3.3 can be written like that. It's slightly less noisy, slightly shorter, and if you are used to it, you will find that much, much more readable. Especially I like how the tests from any unit feels much more natural in this syntax. Of course, it can be used within reason. So this is an example of stable feature. Before feature became stable, it needs to be approved by SIP committee, and before that, it needs to be experimental for some time. Features that are experimental are guaranteed to be implemented and present in the compiler. But you cannot just use them. You need to use them while running not stable version of the compiler. And for that, snapshot releases works the best. So our nightly releases. One example of this feature that is experimental right now, that was approved as experimental by SIP committee, but not yet approved to be stabilized, is SIP47, so clauses interleaving. This feature allows you to have type parameter clauses after the term parameter clauses. So right now, it is not possible in stable Scala to write function making per like that, because you need to take B and put it in the same clause as A, and you need to apply it first, and if you want to have some carrying over that, you need to do some more manipulation with that, and right now, this is an experimental feature that allows you to write it like that. Also, it makes possible to, without any hacks like declaring intermediate objects with apply function, to have heterogeneous maps that have get or else function, because these functions require you to have type bound on some type that is dependent on the parameter that comes before it. Up until now, you need to have every type clause, like the only type clause that you are allowed to have in method definition before every parameters clause, term parameter clause. This relaxes this restriction. So this is the first feature that is right now experimental. I mean, this is the only feature that right now is experimental, of course, sorry. Before feature becomes experimental, so before it is implemented, it needs to be accepted by SIP committee. So those are features that we know we're gonna implement, but for example, PR for them is not yet merged, or even anybody haven't started working on that. And this, we have two features. First of them is really self-explanatory, so binary integer literals. A lot of languages have them, all other JVM languages have them. Why we shouldn't have them? We will have them. And the other one is polymorphic eta expansion. This is something interconnected with clauses interleaving. This allows you to take generic functions and assign them to value. And right now, compiler will scream at you that it cannot infer the type, especially in this case, that it don't know what the generic type should be. But in the future, the compiler will be able to tell that the type of this val is just a generic function. Okay, but what can be accepted by the SIP committee is the SIP itself, so Scala Improvement Proposals. There are many of them currently being debated. Here I have some examples of things that I think will be accepted soon. First of them is a much more flexible syntax for type pattern matches in quotes. Right now, only the first two examples are allowed, but we want it to be much more flexible and have parity with pattern matching in quotes on terms. So, for example, you will be able to do something like in line 4, so unpack a head and tail of a tuple, on, like in line 5, have a match that matches tuple of exactly 3 elements, and see what is the lowest upper bound of all 3 elements, and assign it to type variable t. The next things that is discussed, and I think it has high probability of being accepted soon, is binary API annotation. Lots of people using inlines in their library APIs don't know that anything that you are using from within the inline function, like this private definition X, is becoming public API of your library. So you cannot just change type returned here, because it will break your library. It will break your compatibility guarantees. And to make people aware of that, we want to introduce new annotation that everything that is private or protected or package private and is used from public inline function needs to be annotated with that. And you will know what you can change and what not, and what you cannot change in your API, so you don't break your guarantees. This at first will be emitting the warning if you violate that, and sometime in the future it will become error. If you want to read more about about SIP proposals being currently debated, here is the link and QR code, and you can use that to see everything that we are working on right now. Before something becomes a SIP, there is the step called Precip. So this is a preliminary discussion, and people are coming with lots and lots of ideas, and I don't think there is idea so bad that it is not worth a Precip. The best way to start a discussion is to visit our contributors forum, when all the currently existing feature in the language, currently approved feature, started their way as a Precips, and take discussion there. Probably you will be convinced by some other users that what you want to achieve is already possible by other means, or that your feature cannot be really implemented without breaking any other things in Scala, but maybe you will be encouraged, and maybe someone will help you write a proper SIP. There is also alternative way. It is mostly for the compiler contributors, so people that know the code base of the compiler well, and this is called draft features. Anybody who really understands the code base of the compiler can just write the feature, and after some talks with the compiler team, we are able to include that, and it can be used in the same way as an experimental feature using unstable releases of the compiler. This is because sometimes starting Precip discussions without any implementation is not really productive for people that can just quickly implement them and show the proof of concept that this is possible. And also, it will allow user to experiment with that quicker without waiting for all the steps. Of course, this feature will also need to go through all the steps. So we need to have proper SIP proposal, it needs to be accepted, it needs to have experimental period, and then only it can become stable. And right now, the most important draft feature that we have in Scala are macro annotations. So here you see some pretty simple example with function calculating Fibonacci sequence that is implemented really, really badly and is really inefficient. But we can create memoization, annotation that is implemented as a macro and transform this function, so it actually can be pretty efficient because every call of it is memoized. So yeah, so actually starting with, from now, if you have snapshot version of the compiler, you can experiment with that, but it will of course need to go through all this process. So yeah, so what is, I told you about the features, but what about the future? In this, I mean the future of our ecosystem. There are many important things and many important changes coming. First of them is the process that already started, and this is Scala CLI becoming the official runner of Scala. What does it mean? It means that whenever you install Scala by brew, by some package manager on Linux, you will not get some raw executables with the compiler, but you will get Scala CLI. So you'll get all the features of Scala CLI, like dependency resolution, possibility to configure your JVM, compiler version, etc. If you don't know about Scala CLI yet, please check it out. And if you have any question, then Łukasz is waiting at our stand at the Scala office for you to answer your question. Then there is Scala Toolkit. It also comes. It is already have its early versions, so you can check it out, give you a feedback, but you probably heard much more about Toolkit from talk by Szymon, which was yesterday. Then there is a WebAssembly, which we think is within our reach, but also you already heard about it from Wojtek. Okay, so I had here like 10 more slides when I was going to tell you more about the things that are to come. But then, at the beginning of this week, I went to Lausanne to take part in Tooling Summit, and you may find me somewhere on that photo that was taken 2 days ago. And then I was actually inspired by one quote. One person then, who is for a long time in Scala community, longer than most of us, said that Scala 2 hasn't become successful because some big companies were adapting it. It became successful because startups that adapted it and student projects that adapted it became successful. So, as you see, Twitter, when they decided that they want to use Scala, were still startup-sized. When Spark, which was huge boon for Scala, decided to use Scala, they were just 2 students, not even working full-time on their library, but they became successful. They don't need to consider so much risks as big companies in choosing their technology. And why they choose Scala? Because they knew this is the language that in that time, in that moment in time, you were able to do things that are impossible in any other existing language. Probably you can do lots of this stuff right now in other languages. But I think right now with Scala 3, we are again in the same spot, that we have features in the language that are not present anywhere. And we can do stuff that is not possible in any other language. And during the Tooling Summit, we have lots of examples of that. And I deleted the slides that I originally wanted to show you here, because I wanted to improvise and show you few things that are not possible in any other language. The few things that we are calling the hackable compiler. So, let me change my screen. Okay, you will probably see my VS Code. I can see that you can see that. And here we've got something that I created during the Scala meetup group in Wrocław. I created the core functionality of this. This is a GraphQL client in 45 minutes, giving explanation to that. And how it works, it takes a query, which is quite ordinary string interpolator. You can put some variables here, and it sends it. And this query is just an ordinary string. But what is magical here, if I scroll down and I see that I have result of my query in res value, I have code completion that understands that query. At the top, you can see that there is repository, because this query has, in this string, has object that is called repository. And this repository have field that is called issues. So yeah, so I have code completion for issues. Then I can take nodes, and it understands that nodes is a list, so I can flat map on that. And you must trust me that there is no like downloading schema from the internet here, or there is nothing like code generation. I don't even have build tool here. Everything is built using Scala CLI here, but it works. It is type safe. The compiler is guiding me, showing what fields I have and what I can use. Inside of this flat map, you can see that these nodes, these issues nodes, have fields, for example, labels. So I can take labels and then nodes from that, because this is list of labels, and I can map it to have a name. It is suggesting me the name. And for example, make it into set and print it. Okay, and if I try to run it, okay, you can see that you can see set of all labels that were on last 20 issues on that .e repository. And it executed this GraphQL query and give me like type-safe way to access it fields with code completions, and it just works. I do a lot of GraphQL, and I don't need any other client library. It is so interesting that, for example, you can change something. So, for example, I can make a typo and write issue in our schema and in our query with single S, and now you can see you have a compilation error because apparently there is no issues with two S's. So I need to change that. And now it will compile again. Okay, so this is the first thing. This is this compiler hackery, this is this compiler magic. And the one theme that I think is most important here is that it is guiding the user with this code completion. Other way the library authors can guide users is by something that we are calling right now actionable hacknostics. Oh, sorry. It is a hack, but we are working hard to make it stable. It is already supported in Metals, and within a few releases, it will be stable in the compiler and in the IntelliJ plugin. So I have here some function that is coming from my library. This function is called check and takes a parameter that is string. I can change that string to be not right, but wrong. And when I save it, the macro will say that this is not correct because it was expecting parameter that is right. Okay, so this is nothing special. This was possible before, but when I clicked here, I have a code suggestion and I can apply it. This suggestion was produced by macro. So if I click it, it will change my code. It changed the wrong into right and is compiling again. So the experts can have a powerful tools for creating libraries that are guiding newcomers. It is if your library is crafted right, if it have the right tools, it will be like a breeze for newcomers, and you will be holding their hands and guiding them. And I think this is a future of Scala. And right now, the two things that I show you are not possible in any other language that I knew about. Possibly there are some, but they are niche. But Scala is mainstream, and we can do with that. We have a huge community, and everyone can hack and make the future of Scala brighter. But this is not the end. Sorry.
Isn't it?
There is more. Sorry. There is more, something more. Right now, for many backend developers, the time to market is one of most important metrics. And let's imagine that you have a tool that allows you to define not only your business logic, but infrastructure and deployment purely in Scala and only in Scala, and everything is compile time verified. So if you have some mismatch in your infrastructure or mismatch between your infrastructure and business logic, you will get a compilation error. The compilation can help you and guide you, as I showed you. And everything that can be easily tested, built, and run both on your local machine or deployed somewhere in the cloud, using the command line client that has UX pretty similar to what Scala CLI is currently offering you. And this is not some kind of dream. This is something that are people right now. I know that people that are working hard on that. And I can guarantee that in a year, they will be standing right here and telling you about that. And I guarantee that your jaws would drop. Thank you.
Paweł, thank you so much. Let's try with one question. Do we have a question? I guess they believed you that Scala is not dying. Yeah? Okay, we have a question. All right.
Okay, thanks for the talk. These completions that you showed, are they also some hack? Or is it supported by the IDEs? Is it like a common feature that every IDE could use, for example?
So this is tricky, because right now it is supported in everything that is using the compiler from the completions. So basically you can use it in REPL, you can use it in, as far as I know, it works in Ammonite, it works great in Metals, as I showed you, but still, it is not supported in IntelliJ, but we are in close contact with guys from JetBrains and talking about supporting them. And we have some ideas and solutions for them to make it easier for them. And we were working on that and hacking on that during the Tooling Summit.